evaluate the integral. So we got definite integral of this function, degree 2 on the top, y times y times y, that means degree 3 on the bottom. So this is a proper fraction, that's good. So we want to write this complex fraction as a sum of simpler fractions. So we got already the bottom already factored, that's kind of easier for us. Then this y plus 2 and y minus 3. So this is linear factor, degree 1, so just constant, same thing, just constant, just constant. So we would like to figure out the value of a, b, and c. Okay, for we multiply throughout by the common denominator, which is this, because these three are now separated. It's just y plus 2 and y minus 3. We multiply this by this, that means this is on the top, and this top, the bottom cancels, just survives 4y squared minus 7y minus 12 equals, when we multiply, that's on the top, this is on the top, so y and y cancel, a times the other two factors, a y plus 2 y minus 3 plus y plus 2 cancel, y and y minus 3, b y and y minus 3, y minus 3 cancel, c y plus 2. Okay, this is good for any value of y. So we want to choose y values so that we can isolate a, b, and c. So take a y equals, okay, here is b times y, so y 0. Then b will be 0, this term will be 0, then we can find value of a. Take y 0, 4 times 0 is squared, 0 minus 0, just negative 12 here. 0 means 2 times negative 3, negative 6a. 0 times any number is 0, 0. So negative 12 equals negative 6a, 6 times a by the way. Divide by negative 6, we get a equals negative 12 divided by negative 6 means 2. Similarly, take y equals 3 or negative 2. Okay, because y minus 3 will be 0. That's why I chose y equals 3. 3 squared, 9 times 4, 36. Okay. Minus 7 times 3, 21, minus 12. So that comes out to be 3. Equals, plug in 3, right? 3 minus 3, 0. This is gone. 3 minus 3, 0. This is gone. Just the last. 3 times 3 plus 2, 5. 3 times 5, 15c. Now divide by 15. So c is 3 divided by 15. That means 1 over 5. 3 goes 15 5 times. And finally we take y equals, we can take any other number other than 0 and 3. Since we already know a and c, we can find b. But look at here, y plus 2. How about choosing negative 2? That makes left hand side be. So plug in negative 2 and use your calculator. 4 times negative 2 is squared, minus 7 times negative 2, minus 12. That comes out to be 18. Equals negative 2 plus 2 0. So this term is 0. This is also 0. Here negative 2 times negative 2 minus 3, negative 5. Negative 2 times negative 5, positive 10, 10b. That means b equals 18 divided by 10, which is 9 5. Okay, 9 5s if you cancel the common factor 2. So this complex fraction is in fact a sum of these three easier fractions where a, b, c are found here. So we can write this integral as follows. Okay, so let me write that integral. For now, I'm going to forget about this limits of integration. So then the integral 4y squared minus 7y minus 12 over y plus 2 y minus 3 dy is a over y. So I'm going to write three integrals. Integral a over y. A is 2 over y and dy for each of these three terms, plus integral of b over y plus 2, where b is 9/5 over y plus 2, plus c over y minus 3, where c is 1/5 over y minus 3 dy. And by the way, these numbers can be simply pulled outside, okay, and we need to take limits from 1 to 2. That's in a moment. So let's integrate these. So here, when we take 2 outside, that leaves 1 over y, and derivative of y is 1, so 1 over y is simply natural log of y. 9/5 outside, y plus 2, its derivative is 1, that's 1. When we take 9/5 outside, this 1, so derivative of y plus 2 is 1, so that's natural log of y plus 2. Similarly, 1/5 natural log of y minus 3, plus is not needed because we are in the case of 1 through 2. Now let's evaluate the limit. Okay, let's just do the evaluate the limit. Then thus final, the integral equals, so we just want to go from 1 through 2 of this junk. Okay, that is, first we plug in y equals 2, then we plug in y equals 1. Okay, let's plug in 2. So that is upper limit, 2 natural log of 2, absolute value of 2 is 2, plus 9/5 natural log of 2 plus 2, 4 is 4, plus 1/5 natural log of 2 minus 3, -1, absolute value of -1 is just 1, natural log of 1. And by the way, natural log of 1 is 0. So that's upper limit, minus, plug in 1. Here, 2 natural log of 1 plus, and this is also 0. 9/5 natural log of 1 plus 2, 3, plus 1/5 natural log of -2. 1 minus the -2 is just 2, because the absolute value of -2 is 2. So upper limit, lower limit, and we just saw natural log of 1 is 0. So 1/5 times 0 is 0. And same thing here, 2 times 0 is 0. So the final answer is then 2 natural log of 2, 2 times the decimal number, plus 9/5 natural log of 4, minus, we need to distribute inside, minus 9 over 5 natural log of 3, minus plus minus 1/5 natural log of 2. We may leave here, but we can combine these two natural logs. They got some same number. 2 copies of natural log of 2, and here -1/5 copy of natural log of 2. So 2 copies minus 1/5. What is 2 minus 1/5? 2 is 10/5, so 9/5. 9/5 natural log of 2, plus another 9/5 natural log of 4, minus 9/5 natural log of 3. Okay, we could leave here, because I saw 9/5 in each of these 3 terms. We can factor 9/5 outside, natural log of 2, natural log of 4, minus natural log of 3. You may leave here, but we can simplify further using algebra. 9/5, when we have sum of 2 natural logs, it becomes natural log of product, 2 times 4, minus natural log of 3, 9/5, this is 8. And when we have difference of 2 natural logs, that means natural log of quotient, 2 times 4, 8 over 3. Okay, and this is the final answer.